These are your 7.5a notes on properties of logarithms. So we're actually going to use three basic logarithmic properties, the product property, the quotient property, and the power property, to simplify complex logarithms. So today we're actually going to work with I'll show you the different results, but you can use these properties two different ways. So today we're going to use the property one way, and then the following day we're going to use them going the opposite way. So the product property basically states that if you have log base b of m times n, you can rewrite that as the log base b of m plus the log base b of n. Now, this goes both ways. So I guess instead of saying if, I could have used the IFF, saying if we have a product, we can rewrite that and expand it into two separate laws being added together. If we have the addition of two logs, we can sort of simplify that and make them a product. Now, the reason this happens, in logs, you're describing the exponent. And so when you multiply exponents, we really add them. So if you remember back when we'd say x to the 5th times x to the 4th, you actually get x to the 5 plus 4, which is x to the 9th. So keep that in mind, that multiplication is addition, addition is multiplication. So look at the two examples. As long as you have a common base, it has to be the common base, just like we had to raise the common x in the exponents. So if I have log base 3 of 4 plus log base 3 of 7, I can condense that and call that log base 3 of 28. You don't add them together. It's not 11. It's multiplication. Addition becomes multiplication. And then just the inverse of that, if I already have a product, I can break any product into the sum of two logs. So log base 5 of 20 can be broken into the log base 5 of 2 plus the log base 5 of 10. Or maybe I want to rewrite that as the log base 5 of 4 plus the log base 5 of 5. Or I could even break that into the log base 5 of 1 plus the log base 5 of 20. So any one of those three sums will give you log base 5 of 20. So that is the product property. We are going to concentrate on this form today. So they're going to give us a product and we're going to expand it out. Then the following day, they're going to give the expanded form and we're going to condense it. So if you want to circle or put a star next to this, this is what we're going to focus on today. Or if you want to say this is 7.5a, and then this property we'll concentrate on in 7.5b when we get to it. The quotient property, if you recall, back when we did powers, when you divided, and as long as you had a common base, you would simply subtract the exponents. And so this would be x's to the 5th. So same thing's going to happen here. The quotient property says if you have log base b of m over n, this equals, and we can do a double arrow, log base b of m take away log base b of n. It's always top minus bottom. So again, this works both ways. If you have a quotient or a division problem, you can write it as a subtraction problem expanded. If you have two things being subtracted, you could condense it into one division problem. So looking at the numeric examples here, 12/7 can be rewritten as the log base 5 of 12, take away the log base 5 of 7. If you have a subtraction problem, I can actually condense that and call that log base 3 of 10 over 2, or the log base 3 of 5. So the one simplifies it, the one expands it. Now this one's kind of flip-flopped. We're actually going to concentrate on this today and this tomorrow, condensing tomorrow when we solve. So the top one we're going to be using today. And the third property is the power property of logarithms. And a power property, since we're talking about an exponent, whenever you have a power raised to another power, we multiply those two things. So when you raise a log to a power, we actually can change it to multiplication. So this is the rule that says log base b of m to the p power is equivalent to p times log base b of m. So what it allows us to do is we bring that power down in front. So and then it turns into multiplication. Or if we have it out in front multiplying, we can put it out and make it a power. So again, it can be used both ways. So in the first example here, it says log base 2 of 5 to the third. The equivalent to that is to drop the 3 out in front and multiply it by log base 2 of 5. Or if there's a number out in front of a log, we can simply make it the power of the x value. So in the second example, log base 7 of 4 to the third. Or we could call that log base 7 of 64. Okay, so either way, you can either drop it out in front to multiply or change multiplication into a power. Just for one more time here to show you when we're using these. Today, we're going to concentrate on bringing it out in front to multiply. And then the next day, when we solve these things, we're actually going to make it a power. Okay, so we're just going to try a couple of examples. And when we do these, we're just trying to get creative, but I do want to explain these crazy decimals. On your calculator, some calculators have it, but the majority don't. And if your calculator has it, you will not be allowed to use that calculator. But if you're allowed to type in log base 2 of 3, it will give you 1.5850. Again, not all calculators have that ability, but if yours does, you won't be able to use it on the quiz because that defeats the purpose. But what this is really saying here, remember when you evaluate log base 2 of 3, what power do you raise 2 to get 3? And the answer is 1.5850. So since every calculator doesn't have that option, they give it to us. So the book's going to give us that decimal. Then they said, based on that one value, based on that one decimal, I want you to find log base 2 of 48. So what we're searching for is what do you raise 2 to get 48? We can kind of narrow it down. I know that 2 to the 5th is 32. That's too small. And 2 to the 6th is 64. That's too big. So my answer is going to be 5 point something. Now, guess, check, and revise could get you there, but it's not going to get any points because this is all about using algebra, so it's more accurate. It's not guess, check, and revise. So what I have here is I have base 2. So I need to somehow rewrite 48 as a product of 2's, as a quotient of 2's, or as a power of 2's. But the hidden number I have as well is any power of 3. I'm sorry, I have 3, but then I have the powers of 2. So I have to use just these two numbers. So I have log base 3, so I guess I said the wrong number. I apologize. I got to rewrite 48 in terms of 3, either product, quotient, or power of 3. But I also have the 2, because remember, any power of base 2 to whatever power, we have this little tool of the inverses. So I do have powers of 2 as well. So I'm just going to kind of go off to the side and see if I can rewrite 48 as powers of 2's and 3's. So I'm breaking it down, 6 and 8. There's a 2, there's a 3, there's a 2, there's a 4, there's a 2, there's a 2. There's my 2's and 3's. So the 2's and 3's come from the log. The base I can use and the 3 I can use. And so when you're all said and done, 48 is really 2 times 2 times 2 times 2, or 2 to the 4th times 3. Okay, and you can check that, plug it in your calculator, it should equal 48. So the very first step, the thing that we do, is we say the log base 2 of 48 is equivalent to the log base 2 of 2 to the 4th times 3. So the very first step is rewrite. We rewrote 48 in different terms, in 2s and 3s. This right here on the left just becomes a label. This is what we're trying to evaluate. So log base 2 of 48 then is equivalent to 2 to the 4th times 3. But I rewrote this as a multiplication problem and a power. So it's a multiplication problem. I'm actually going to separate that and change it to addition. So log base 2 of 2 to the 4th plus log base 2 of 3. So I rewrote 48 as a product, quotient, or power, which it was a product. Then I take the product and I write it as an addition problem because products are addition. And now I'm going to substitute. So this just stays my label. Log base 2 of 48 is equivalent to, when I evaluate log base 2 of 2 to the 4th, these cancel and I'm left with 4. When I substitute, they gave me what log base 2 of 3 is, 1.5850. So I evaluated my base 2, I substituted my log base 2 of 3, and now I just simply have to add that together. So log base 2 of 48 is 5.5850. And if you look at our little corner over here, we said it would be 5 point something, and there we have it. Okay, we're going to try another one. So the hardest part is figuring out what you're going to rewrite that number as. So we have to get 250 using just 5 and 2. Powers of 5 and powers of 2. Because 250 is larger, I'm thinking we're going to either square something or cube something or multiply. I don't think we're going to divide 5s and 2s to get 250. So kind of use that as your understanding. We're going to come up with a product. So again, off to the side, I'm going to do some preliminary breaking down. 5 times 5, 5 times 2, and there we have it. 250 is 5 cubed times 2. So instead of writing 250, I'm going to write 5 cubed times 2. So we start off with our label. Log base 5 of 250 is equal to log base 5 of 5 cubed times 2. We rewrite. Now we're going to bring in the property. So since I rewrote it as a product, I'm going to expand. Log base 5 of 5 to the 3rd plus log base 5 of 2. Multiplication is addition. I just expanded it into separate logs. Now that I have the separate logs, I'm going to substitute and evaluate log base 5 of 250. When I have the log base 5 of 5 to the 3rd, that becomes 3. And log base 5 of 2 was given to us as 0.4307. When I add those together, log base 5 of 250 is equivalent to 3.4307. And there you have your answer. What would you raise 5 to get 250? You could check your answer. If you raise 5 to the 3.4307 power, you should get close to 250. Again, we're rounding. Okay, and the next one, they gave us a couple of values. So they gave us the value. We can use 6, 8, and 32. We have 3 numbers that we can use. And we got to come up with 4. So using 6, 8, and 32, I got to come up with 4. All 3 of those numbers, 6, 8, and 32, are larger than 4. So I'm assuming a division is going to occur here. And looking at these numbers, I see a division between 8 and 32. So I didn't have to use 6. You don't have to use all of them. It's just available if needed. So I know that 32 over 8, I can write it as a fraction or a quotient, is equivalent to 4. So let's just take some time with your calculator and understanding numbers so we can go ahead and get started. So log base 6 of 4 is the same thing as log base 6 of 32 divided by 8. Saying the same thing there. So I rewrote it. So the log base 6 of 4 can be rewritten in expanded form as log base 6 of 32. Take away log base 6 of 8. We expand. Rewrite, expand using the property, and then substitute. So log base 6 of 4 is equivalent to the decimal they gave me here, 1.9343, take away the decimal they gave me up for 8, 1.1606. And so the log base 6 of 4 is equivalent to, if you use your calculator, 1.9343, take away 1.1606, 0.7737. You can always check your answer by saying, if you take 6 to the 0.7737 power, does it equal 4? And it should, or really close to 4, because we're rounding. All right, number 4. Number 4, I'm just going to set up. I'm not going to actually go through and calculate, but the 3 numbers we're given are 3 for the base, 5, and 20. And so we need to come up with 1/4. 1/4 is very small. I see 5 over 20. So we would use the quotient property again. And number 5, I'm actually going to have you guys do as your practice problem. So really quick, just using the rule, no calculators, no decimals needed, give me the condensed form of this. If I have log base 3 of 12 and I'm taking away log base 3 of 2, what could that be written as? Condense it using the quotient property. And then your practice problem is I want you to evaluate number 5 and show all the steps. Good luck.